I want to take a look at a couple of student responses to this final exam as a way to examine student thinking and to also share some thoughts about my own personal approach to grading exams like this. Here, in the very first question of the test, a student does a couple of good things. She identifies the distance, the stopping distance. She vaguely refers to the acceleration, and I think by looking at her work over here, I can tell that she has indeed identified that number as the acceleration. She has also correctly identified that the final velocity should be 0. What she's done, however, in this area here in the upper right-hand corner is she's selected an equation that has two unknowns, the stopping time and the initial velocity. And you can kind of see her thinking kind of grind to a halt here as she can't quite write down what the initial velocity is, but then somehow sort of comes to an answer. And my guess is that she probably just divided this number by that and ignored the minus sign, and anyway, just sort of got to some initial velocity by misapplying the information. I gave her half credit, 1.5 points off out of 3. But then in the next step, where the students are asked to find the stopping time, she selects the right equation, has the right final velocity, the acceleration, and the initial velocity. And even though this answer is wrong here, this time is wrong, her thinking is correct, and I kind of scribbled here, given above. I'm not handing this test back, so that doesn't have to be legible, but more of a note for myself that's why that was marked correct. This question about the exchange of energy from all potential energy to a variety of other kinds of energies was done properly by the student. She was able to kind of work the problem from the beginning to create these bar graphs, and made a slight error here at the end by misapplying one of the energies. But what I'd like to focus on is the fact that I had provided an initial height of L and a certain amount of potential energy at that point, and then at point D here I had identified that height as L over 10. This student went ahead and calculated, based on the potential energy and other variables, what the height was, which is fine, but it's an unnecessary step. So this calculation here of the height is not necessary. If you know the potential energy at L meters is 1530 joules, then at L over 10 the potential energy must be 153. So I would say about a third of the students who got this question right went ahead and calculated that height, even though it was not essential.